First, we will begin describing the threshold of excitation. Originally, a cell's membrane is at negative 70 millivolts at resting membrane potential. Now, we will have to reach the threshold of excitation. This occurs when sodium channels open and a depolarization begins. Next, sodium channels will close. This results in a repolarization. After repolarization occurs, the cell is going to dip below our threshold of excitation and hyperpolarize. Next, we will remain up to a resting membrane potential and prepare to reach the threshold of excitation again. Next, we will be describing gated channels. These are channels that require something in order to be activated, open, or close. We have several different types. Two that we will discuss are chemical and voltage. Chemical requires a certain chemical in order to open or close the gate, and voltage requires a certain amount of volts in order to open or close. Now, these gated channels can have different types of responses. One being excitatory, which is when an action potential is more likely to occur, hence excitatory, and inhibitory is when an action potential is less likely to occur. Next, we will describe the different types of responses that these can have. Now, the excitatory postsynaptic potential, or EPSP, is produced by the opening of Na channels via a neurotransmitter. These channels open up, allowing Na to enter the cell membrane, making it more positive. The more positive a cell is inside becomes the more likely you are to have an action potential. Next, the inhibitory postsynaptic potential, or IPSP, is produced by the opening of chlorine or potassium channels via a neurotransmitter. Now, when the potassium channels open, allowing potassium to exit the cell, making the inside more negative. Now, when chlorine channels are opened, they are allowing chlorine to enter the cell, causing it to become again more negative, hence inhibitory response. Is that good? Yep. Next, we will describe the different types of summation that can occur. First, we have spatial. Now, this occurs when on the synapse you have a dendrite connected to your different A, B, C, and D terminals. Now, when A and B are combined, this elicits an excitatory synapse or response. As you can see by the chart, when they are alone, they do not create a large enough response. But when they are together, they create a large enough excitatory response, thus allowing an action potential to occur. When A and C are paired, they are going to cancel each other out, as one is excitatory and one is inhibitory. Nothing will occur. When C and D are compared, they are inhibitory, so therefore they're going to cause an inhibitory response. But again, they will not produce a large enough response alone. When they are paired together, they will induce inhibitory. Describe temporal. This is when we have excitatory and inhibitory acting together over time. When A fires slowly, you will not produce a large enough, but when it fires quickly, you will produce a large enough action potential. When B fires slowly, you will not have a fast enough inhibitory, but when it fires quickly, you will. We're calling it.